Hello friends, welcome to Tech Now Work. Before we proceed into the details of the subject, I request you to like this channel and subscribe, so that you don't miss any update. In previous video, we have discussed about types of flange faces and their applications. In this video, we will discuss about different types of gaskets used in piping systems. First, we should understand the need of gaskets. As you may be knowing, the leak-proof metal-to-metal surface joints, in which the gaskets are not used, are very difficult to fabricate. Because even by the use of highly accurate machining we cannot eliminate microscopic surface irregularities between metal-to-metal contact. A relative soft sealing material is required to fill these surface irregularities. The material used to fill these surface irregularities is known as gasket. The function of gasket is to interpose a semi-plastic material between the flanges, which deforms under load and seals these microscopic surface irregularities to prevent leakage of fluids. The amount of force that must be applied to the gasket to make it flow and seal the surface irregularities is known as the yield or seating force. The seating force is applied by tightening the flange bolts prior to the system pressurization. When the system is pressurized, the hydrostatic force will tend to increase the tensile force on the bolts and unload the stress on the gasket. The remaining stress on the gasket after system pressurization is known as operating stress or residual stress. This is the stress at which the gaskets are expected to operate, and it will determine the degree of tightness achieved by the joint. If the hydrostatic forces are significantly large, then residual stress on the gasket may reduce to a critical value and leakage will occur under internal pressure. Also, it may be possible that the gasket may blow out. Materials having high elastomer content are expected to relax significantly as the properties of elastomers decays with temperature. It should also be noted that thick materials will relax more than a thinner sheet of the same material. This is why experts will recommend that the thinnest gasket possible should be used. However, it should be as thick as is required to accommodate flange distortion and misalignment. The selection of gasket type and the materials are affected by multiple parameters, like surface finish of seating faces, type of flange face, service factor calculated based on pressure and temperature, types of fluid, gasket factor and minimum seating stress, and many more. We will cover this in separate video. Now we will discuss the type of gaskets. The gaskets can be classified into three main categories, which are non-metallic, semi-metallic and metallic. Semi-metallic gaskets are used for higher duty applications involving high pressure or temperature, higher flange loadings and high process flows. The combination of non-metallic filler is used to provide compressibility, and the metal for strength, resilience and chemical resistance provides a more reliable gasket in many conditions. Often used semi-metallic gaskets are spiral wound, camp profile, corrugated metal gaskets, metal jacket gasket and a variety of metal reinforced graphite gaskets. The most familiar semi-metallic gasket is the spiral wound gasket, which is widely used on high-pressure joints. A profiled strip of metal is wound into a spiral with a layer of gasket material interleaved between the metallic spirals. A variety of configurations are used depending on the type of flange and their application. With this design of gasket, the metallic strip resists the pressure forces, and because it is loaded onto the flange faces it will provide some sealing. The softer gasket material fills the surface irregularities of flange face, and create high integrity sealing. The flexibility of the spiral winding provides improved sealing force retention during cyclic operation compared with a flat face gasket. The outer ring is used for centering and the internal ring used as an additional compression limiting stop. The internal ring prevents the gasket from buckling. It also serves as a barrier to protect the gasket from heat, corrosion and erosion. Metallic gaskets can be fabricated from a single metal or a combination of metallic materials, in a variety of shapes and sizes. Metallic gaskets are suitable for high temperature and pressure applications, particularly where reliability is critical. In general, gasket compression loads need to be high to deform the gasket, and the metal used for the gasket should be softer than flange faces. The hardness of the ring should be at least 30 bhn less than the hardness of the flanges to prevent flange deformation. Often used metallic gaskets are ring-type joint, are X-type, BX-type, flat, lens ring, etc. Ring joint gaskets come in two basic types, an oval cross-section and an octagonal cross-section. Both are machined from solid metal, and are designed for high-pressure, high-temperature service conditions, which require a special joint design with high degrees of surface finish on the flange faces. The working of ring joint gaskets can be explained by the axial compressive load causing them to deform and fill the flange groove irregularities. As the load-bearing area of ring joint gaskets are very small, which produces high surface stresses between the sealing face and the groove, and making it poor in recovery characteristics and unfit for reuse. The oval section ring creates a contact area of stress concentration, but this is not well defined. However, the octagonal rings concentrate the stress in the differential taper and will perform more reliably. The octagonal cross-section has a higher sealing efficiency than the oval and would be the preferred gasket. Dimensions for standard ring joint gaskets and grooves are covered in ASME-B 16.20 and API 6A, API 17D. Non-metallic gaskets are manufactured from aramid fiber, glass fiber, elastomer, polytetrafluoroethylene, graphite and minerals, etc. Non-metallic materials are suitable for a wide range of general and corrosive chemical applications. These gaskets are suitable for low and high temperature applications, depending on materials used. Their use is generally limited from low to medium fluid pressure applications. Non-metallic gaskets are also typically the least expensive of the three gasket categories. Non-metallic soft gaskets are available as ring type, full face, and also available in custom shapes for specialty flanges.